Hi folks, I'm Florian from iProcess and today we talk about boxes in testing. This is an entry-level video, so if you are new to the field of testing as a junior or cross-mover, this is for you. For all of you who are not too familiar with terms in testing, you're welcome to stick around as well. In testing, we generally refer to three different box colors: black, white, and gray. And when you look them up, you will find very often references to code and code visibility. For this video, we are looking at the different boxes from a system point of view. So let's pick up an example, DUT. That stands for Device Under Test. Here's a simple one, a brake light controller. In an electric car, the brake light can be triggered by two sources: the brake pedal, either driver or ADAS actuated, or the regenerative braking from the motor inverter. The controller for the light has two inputs, the analog signal from the pedal switch and the CAN information from the inverter. The analog signal goes through an analog to digital converter, or ADC, to the microcontroller, while the CAN information is coming through a CAN transceiver. The microcontroller consumes both inputs and turns the brake lights on accordingly by commanding a gate drive unit, or GDU, to open a half bridge that then will provide power to the light. Again, simplified architecture for the purpose of this example. Let's start with black box testing of our example. Your test only utilizes the external interfaces available on your DUT, in this case the CAN input and the analog request. You will cycle through the different input options while checking on the output, and it will be looking like that. CAN off, analog off, lights off. CAN on, analog off, lights on. CAN off, analog on, lights on. And CAN on, analog on, lights on. Moving on to the white box. In this case, you do not use the external interfaces at all, but instead you are using internal interfaces. That can include one or more of the blocks in here. So for example, you modify the signal from the ADC to the microcontroller and look at the output of the microcontroller, or you look at the output of the GDU. Both white box tests, just the former is a module test for the microcontroller, the latter is an integration test for the microcontroller and GDU integration. Now, gray box testing is a hybrid between white and black box testing. For gray box test, you can either use external inputs and read from internal signals, or the other way around. Let's look at our example. By applying information on the CAN and the analog external interfaces and reading the output of the microcontroller, or by applying a signal to the GDU and then reading the output at the brake light, you perform a gray box test. Also, fault injection tests are tending to be gray box tests. You inject your fault somewhere into your system, like a broken connection between the ADC and the microcontroller, and you are looking for a safe behavior at the output of the system. In general, boxes are getting darker, if you will, the higher you get in the integration of your system. But it is not mandatory to run them like this, it's just a proven practice. Also keep in mind that your system can become a component when it is integrated in a bigger system. So while you are testing black box, the integrator of the system of systems runs gray box tests on the architecture. The box color is always a question of perspective. iProcess can help you derive and define your custom test strategy in the most tailored and efficient way for your company, yet with all necessary compliance in mind.